We are working on the wind turbines. We are students in the D.I.Y University and our client is MSF. We checked the feasibility, desirability and viability and led us to 3 different types of blades. And we selected the classical horizontal one because it's more efficient, rotates faster so it creates more energy, easy to manufacture and uses cheaper materials. As a reference we used the wind speed in D.I.Y, which is 3 meters per second. The first location is the biggest refugee camp in Africa, located in D.I.Y, Kenya, with a wind speed of 4 meters per second. The second location is a Syrian refugee camp in Turkey, with a wind speed of 1 meter per second. The third location is a disaster camp after an earthquake in Haiti, with a wind speed of 6 meters per second. The fourth location is a disaster area after flooding in Chennai, India, with a wind speed of 3 meters per second. Here we see the turbine placed inside of a disaster campsite in the Syrian refugee camp in Turkey. They will be using the turbine to charge their devices. So who are the users? The users are people in disaster areas, for example refugees, to contact family members, or people in hard accessible areas, for example desert or mountains. The reasons for using the wind turbine are to charge their basic devices, for example their phones or lights. On the left you see the final concept of the turbine. On the right you see the different parts. You can see the generator with the diode, the battery and the pole, the blades and the bottom stand. The turbine is delivered in a box and easily set up by the user. For extra weight, water or sand can be poured into the stand at the bottom to make it more stable. The electronics will be protected in the upper part. The final concept weighs 3 kilograms. The dimensions of the stand are 48 by 48 by 4 centimeters. The turbine's height is 1.15 meters and the length of the blades is 29 centimeters. Now I will show you a video of the testing we done. Our future plan is to make the electronics work. This means we have to make sure the turbine charges the battery. With help from professionals in the field of electronics, we want to obtain this goal. We ourselves will buy an already existing product and will look at it to find out how it works. We want to do more testing with blades and the users. We ordered a wind speed sensor to know the exact wind speeds during testing. And we ordered a hand dynamo to reverse engineer it.